Welcome to the deep dive. Imagine a tool so powerful it could predict Earth's future climate, like with astonishing accuracy, looking deep into all that chaos defining our world. This isn't sci-fi, right? It's the very real promise of something called Orbit AI.
Yeah, and some are saying it may already know what's coming for the planet.
That is quite a statement.
It is. And that's Orbit AI, the focus of our deep dive today. It's being called the world's largest open source climate foundation model.
Okay.
And its whole purpose, really, is simulating and predicting Earth's environmental future using, groundbreaking AI.
And for this deep dive, we're looking at a really interesting cinematic video package. It's from EarthScope Studio, and it brings Orbit AI to life quite vividly.
Right.
So our mission today, let's explore what Orbit actually is, how it was trained, what's it telling us already about extreme climate events, and crucially, its potential impact, down the line.
Okay.
Let's start with just understanding the sheer scale of it.
Well, what's fascinating is Orbit isn't just some idea. It's a huge 113 billion parameter climate AI model.
113 billion.
Billion, yeah. Its scope is incredible. It's built to predict really complex environmental systems. Think oceans, land, ice, the whole picture.
That sounds absolutely massive. Who are the brains behind this? The scientists, the tech people?
It's a serious collaboration. We're talking scientists from Oak Ridge National Lab and NVIDIA.
Okay, big players.
Exactly. Combining their expertise and the training. Well, that was a feat in itself. They used the fastest computer on Frontier, yeah. And they fed it this immense data set, something like 4.2 million climate simulations from CMIP6.
Wow.
Which is, a huge collection of global climate model outputs, plus other real-world data, too. It wasn't just number crunching. It was teaching an AI to really learn from this massive, diverse planetary data set.
And speaking of crunching numbers, that computational power. Frontier, the world's first exascale supercomputer. What does exasc actually mean for, the rest of us?
Yeah.
Well, it's almost hard to wrap your head around. An exascale computer does a quintillion calculations per second.
A quintillion?
A 1 followed by 18 zeros. So put it this way. If every single person on Earth did 1 calculation per second, it'd take us, over 4 years?
Wow.
Frontier does that in 1 second.
Okay.
And that immense power, that's what's crucial. Simulating Earth's climate, it's incredibly complex, chaotic.
Right.
Historically, climate models, they struggled with long-range accuracy, predicting those really localized, intense events. This exascale power, that's what lets them make forecasts for specific things, say 60 days out.
60 days.
Yeah. Moving from just broad trends to, actionable long-term predictions, things people genuinely thought were impossible until now.
That sounds incredible theoretically. But the big question, I guess, is, has Orbit AI actually shown this in practice? How's it doing against the existing model?
Oh, it's delivering, absolutely. In its early tests, Orbit didn't just, keep up with traditional systems. It significantly beat them. Yeah. Specifically, it outperformed models like ECMWF, that's the European Center for Medium-Range Weather Forecasts, sort of the gold standard.
Right, I know them.
Orbit beat them in 60-day forecast accuracy. And that's the key point. It gives us this extended lead time we just haven't had before.
60 days is. Yeah, that's a game changer. Imagine preparing for a major hurricane 2 months out, not just a week.
Exactly.
That's the difference between, effective evacuation planning and just reacting when disaster hits. So what specific kinds of early warnings does that kind of lead time allow?
We're talking concrete things. Orbit can spot critical events like atmospheric rivers, the ones that bring heavy rain, heat domes causing extreme temperatures, significant rainfall anomalies, all weeks ahead of time.
Weeks?
Yeah. Which it does raise that important question. Imagine the proactive steps we could take with that kind of foresight.
That's a profound thought. It really makes you think how much less reactive we could be globally. So just to be clear, this isn't just a lab experiment anymore. Orbit is actually modeling current and future events in the real world.
It really is. It's modeling real-world scenarios right now. For instance, tracking heat domes over Europe, identifying wildfire risks in Canada, even anticipating shifts in monsoon patterns, which are vital for agriculture, water resources.
Huge implications.
Yeah, in so many parts of the world. What really stands out is its immediate practical application. It's not just theory.
So if we zoom out, then look at the bigger picture, what are the future implications here? How could climate AI, like Orbit, fundamentally change how we even interact with climate data, on a global scale?
Well, it truly could be transformative. AI like Orbit, it has the potential to become like the fundamental basis for international disaster planning,
Right.
providing insights that could save countless lives, minimize damage. Beyond that, think about carbon accounting. It could revolutionize it, give us much more accurate ways to track and manage emissions globally.
And the sources we looked at even mention its potential role in climate geoengineering, which is, a whole fascinating, maybe slightly controversial area.
It is.
For listeners, that's generally large-scale interventions to counteract climate change, right? Like managing solar radiation or pulling CO2 straight out of the air.
Exactly. So, yes, from prevention and planning to potentially, actively intervening with the planet's systems, the implications are vast.
Which obviously requires very careful thought.
Indeed. This transformative potential is enormous. And yeah, it absolutely requires careful consideration. How we apply it, the frameworks we need for such powerful tools.
So to kind of wrap up the vision for Orbit, we're looking at a revolutionary AI, one that sees our planet with this unprecedented level of insight. It's connecting data points, finding patterns no human ever could, like an all-seeing eye on Earth's climate future.
That's a good way to put it.
This model sees our planet like no human ever could, but can we actually use its predictions to save the future? Or, will we just ignore what it might already know? It really leaves you with a profound sense of responsibility, doesn't it?